Yeah, I need to change earpiece. I need to do everything over there. Yeah, the teacher go through paper. No. They're going to go through? No. Yes. No, no, no. Don't tell me that. What do you mean by they're not going to go through? That's then BS stuff.
Shamila didn't go through. She's finishing A5.
No, but why is he saying that he doesn't want to go through? What's this? You only give us like an answer sheet. That's it. If there are any questions or something. Not a response. I agree. I need a sorry. This is Gabriel sent the clean copy, right? You help me watch as I'm doing, right? If your next question is not the same, then you let me know. Then I go to I'm trying to do both sides. Because whatever you guys need to do, they have to do also. I don't know whether or not you got extra questions from on top of theirs. Wasn't that thermal or something like that? No. Gas loss. Gas loss. Wasn't there gas loss or something?
Like one question.
One question. Okay, can fine. Yeah, hang on. This is the SL side of things. This is the HL side of things. So I'll just put them side by side first. Right, the SL side. Let me just do a quick rundown on this. Okay. Wait. Why blur on this one? Oh, okay. So, is it the exact same paper? No, right? Oh, you got 30 more marks than US. Okay. 40 more marks. Oh, no way. Okay, can. Okay. First one, G-Fuse. You all were quite shocked by all the definitions, But it's not the first time, right? I think the last CT also we talked about it. We also said that they had a lot of definitions, right? So you have to figure out how to get your definitions done, right? Do I have a list? Yeah, I have a list. I have a definitions list somewhere, right? So you have to go and you have to go and I don't know whether I uploaded it yet. Okay. G-Fuse strength at the point. Anyone with an answer, but like there was a discrepancy or you're not happy with how they marked it. Was there any? Well, it'll be the force per unit mass, right? Force per unit mass, right? At a point in space, right? I think that's pretty much it, That's all, right? There's nothing much else there. This one, this question here. Oh, this one. Wow, I told you already. I think sometimes I mention it, but then sometimes maybe I feel like I didn't say it 2 times, 3 times, 4 times, 5 times, then it doesn't register. Don't know why so. Oh. Okay, the thing is this, okay, and all the sample papers that I've been looking at so far, right? Somehow, right, you don't highlight this one, no. If you're doing this kind of papers, right, like in your like realize that, I don't know whether you realized it, they're trying to trick you. They are trying to trick you from the surface. From the surface, the G-Fuse strength is 9.1, right? Determine the G-Fuse strength at a height of 5.61, okay? Okay, now if you're not sure, right? So if like I don't know who this is, right? So if you're not sure of how to do the calculations, I think there was like a lot of attempts at it, right? Draw the planet. Yeah, draw the planet, man. Let's draw the planet. The planet here is like this. Draw the planet. This at R, right? At R is 9.8. Okay, at R is 9.8. The question is asking you, right? At 5.5. What a weird random number. 5.61 R. Okay, what's the G there like this? Okay, right? Then you should understand that that's total distance 6.61 R. Okay, so your equation will be something like okay, so Gm over R squared, that's G-Fuse strength, all right, is equals to 9.8. Like literally you've used R. Please notice this, your data booklet equation for G-Fuse strength. What's the equation? Look at the data booklet equation. Tell me what's the difference between what I wrote here and inside the data booklet. Yeah, it's small r. In the data booklet, small r. So in the data booklet, okay, data booklet equation, the G equals to Gm over R squared. That's small r. What does small r represent again? One more time. What does small r represent? Come on. Distance from center to some point. Right, to some point. Please do not misquote R as radius. Don't misquote it as radius. Don't misconceive it as radius. It's not radius, right? It's just the distance, right? Yeah, I hate this equation. To be honest, they should have changed it to GM over D squared for the longest time. I don't know why also. But then in this working here, I'm showing you GM over R squared because I'm literally using the radius of Earth as there's a small r because we're talking about the surface, so 9.8. And therefore, the other equation that you're trying to get at is G, right, M over 6.61 R whole thing squared equals to what? Right, there you go, right? So then you have to do the math, okay? Then you have to do the math. So if you have to, please draw this thing. They don't penalize you for drawing diagrams on, right? So if you are doing corrections now, if your teachers are not going to go through this, but please draw this in, draw this diagram here. Draw the surface here, draw that point there, right? Write down the two equations, right? This one, I leave it to you because this one is your math stuff, right? So I'm not going to touch it. This is the thing that I teach, diagrams. Okay, okay. The next one, oh, sorry, what? Right, so basically you just need to take 6.61 squared as the denominator here, right? And then 9.8 divided by that. That's your answer there. So the answer here is 9.8 divided by 6.61 squared, right? So that will be your answer. Okay. Small things, please remember to put units. If you don't put units, then you're done for. So right, then you lose the marks for nothing, right? A bit wasted. But yeah, okay. So what's your bottleneck? Because I actually did see a lot of people get this one wrong. So what's the bottleneck? I think the bottleneck is firstly not visualizing the scenario. This is surface. Okay, this is surface, and then this is 5.61 away from the surface, right? You need to underline the word surface. Make sure they don't get to trick you, right? Distance of 6.61. Okay, IB has done this before. I think this is an IB question. I think so. Yeah, if I'm not wrong, or maybe just some changes in the numbers or something like that. But yeah, this thing here, they love doing the surface thing. IB loves doing the surface thing, right? They love setting like question based on surface. So don't get tricked. The other question that so not IB, ACS, right? ACS exams 1 year ago, they didn't use surface. They use altitude. They say that the altitude of 5.61 R. Walao, English lesson altitude. Altitude is above the surface, right? So at the end of the day, like that's all that. So you have to be very sharp at that, right? Visualize it, then you put down the appropriate equations. Yes, I know if you're not used to this, right? It might take some time to practice, but please go ahead and do it, right? So draw it out, right? Then it becomes a lot clearer. Okay, the next question, part 3. Yeah, I hate this question. This one here, right? I looked at it already, and then I'm just thinking, right? I would just let the 2 marks go, because that's just like there's too many numbers. My eyes are jumbled up already. Hey, but you all got it, Actually, most of you got it actually. But yeah, so we gotta see how to do this. What's that? So they're comparing the mass of Saturn and the mass of Earth, right? Sorry, mass of Saturn, mass of Earth, radius of Saturn, radius of Earth, and they ask you to find what's the G field strength on the surface of Saturn. Okay, good. All right. Can't visualize? Draw. All right, draw. So Earth. Okay, Earth is like this. This is R of Earth. Okay, then 9.8. Then Saturn. Saturn is bigger, right? Saturn is a big giant gas planet, right? Saturn. Okay, right. And this is the G of Saturn that we don't know. Okay, but we do know that the radius of Saturn is like this. Okay, so you can after this you can write down the equation again. So you got your G M of Earth over R of Earth squared, right, equals to 9.8, right? Then you got your G M of Saturn over radius of Saturn whole thing squared equals to G of S on the surface of Saturn, right? Don't know what it is. And you have to basically manipulate these two equations and then use these two here like that. Okay, like you have to use a ratio and a ratio of the radius. Okay, yeah. So I have a similar question in my A levels. I have a similar question in my A levels. Okay, my A level students have a similar question. That's a little bit more trickier. They didn't give the mass, they gave the density of the planet. Wow, density. That means you have to go and find the mass over volume. That was damn extra. Those kind of things are just damn extra, right? So I mean, we don't have to go there, right? We don't have to do that kind of like complicated math, but we at least need to know how to mess around with this ratio given here, with this equation and this equation. I mean, how would you do it? How would you do it? You know what? I would always understand that there's two equations, right? Then my mind simultaneous. I just try to figure out my simultaneous equations, right? Like the methods we use in simultaneous equations. Like this is equation one, right? This is equation one. This is equation two, right? Okay, equation one, equation two. Just do this, equation one divided by equation two. Right? Just take equation one divided by equation two because the other way around. Take equation two divided by equation one, right? Because then I can follow the ratio they gave me. Mass of Saturn over mass of Earth. Right? Take this equation, divide by the equation. Okay? Right? I literally will leave it to you. This one here, I don't think I can have any value add already after this point. Okay, so SL starts to talk about E fields, HL starts to talk about this one here, gravitational potential. Right? So for HL, let's look at this first. Does HL have this one later on? Don't have, so this one I go through separately for SL in a while. Okay? What's this? What do they want? Proving Walao, a lot of work
Proving based on the equation.
But a lot of work Oh, there's a lot of work this one. Okay, wait. Okay, I slow down. Okay, you know what? Sorry, I missed the first sentence. I didn't read the first sentence and I thought it's very difficult. I forgot about the first sentence. Look at the first sentence. Right, what's the first sentence? What's the key phrase in the first sentence? Orbit. Right, orbit. Then you ask me for GPE. I will just skip this question. I would. I mean, I'll come back to it later. It looks like a lot of work for very, right, not worthy. Right? Does it affect my next part? I would have read ahead. Right, I'll go ahead and read the next one.
It won't
Shit.
because they,
Huh? It won't, man?
because they already gave the equation as well.
Oh, because they say deduce, right? That means you're supposed to use this for the next part, right? Okay, fine. Okay. But how do you do this now? So like part of it is also exam strategy. You go in, you sit down, you can't, if you feel that this thing is gonna waste a lot of time, then you gotta learn how to let go, right? Go, next part. Ayo. So this is the distance r of the satellite, and this is the r of the Earth, and they want to give you a GP, right? Okay, then you write GP law. So what's the expression of GP of a satellite? Negative G over small r, over small r. Okay. So your job is to try to manipulate this into that, is it?
Yeah.
What the pong? I'll try to squeeze in something. What else can I write?
Linear working.
Huh? Oh, what the? Hey, wow, this damn dumb lah. Oh my god. Hey. Okay, so the problem is this GM, right? This big GM, right? You look at this, this thing doesn't have big G, doesn't have big M, right? Okay, you got to get rid of it. So you use the equation over there. G big R squared equals to GM. Sub this thing inside here. Then that's your answer already. It's a frustrating question. I sit down here thinking like, but actually it's just this one stupid substitution only. Okay, so you just make GM the subject because okay, so the strategy is this. I've written down the equation for the satellite. I look at the equation they want me to show it as. I go and try to spot the difference. Big G and big M are not there. Then they're asking me to use the above expressions. Okay, so I have to look back at this one because I already used this one already, right? Or maybe this one here. So this one here shows me that the GM can be written as GR squared, right? Then that's the case I sub it in, then it will disappear. And then that'll be the answer there. I also don't know. This 2 marks here for nothing. Okay, come, next one. The GPE of the satellite, the surface of the planet is this. Then deduce that the GPE of the satellite and the orbital radius of this is that. Okay. Whoa, how will you do this? Okay, so it's again draw right. Draw the object. The GPE of this guy is what? Oh, I need a clean sheet, man. This thing is very messy. You all can see it? Yeah. Okay. Okay. So this one here is I just have to write it out, right? You just force yourself to write it out. So GPE equals to what? Negative G big M small m over big R, right? Because that's the GPE of the satellite at the surface. Okay? Can? Right? Which is negative 9.6 times 10 to the power of 10. Okay, like that. Do you have the radius of the Earth?
Yes.
Oh, shoots. Yeah, they gave it there. Yeah. So no, okay lah. Okay, so since you have the radius of the Earth, what can you use this to find? You can find GMM, right? You can use it to find GMM. You get it? You can use it to find GMM. Okay, then they ask you, so what's the GPE when it's further away? When it's further away, when it is 4.3 times 10 to the power 7 meters away. 4.3 times 10 to the power 7 meters away. Then you just write negative GMM over 4.3 times 10 to the power 7 meters away equals to how much? That's what you're trying to find, right? Okay. Since you can find GMM from the first equation, then you sub in the GMM to this side, you can find the answer already. Okay. But this question is a bit technical, right? So that means that they open the paper with a technical question to try to shock you, because that's what they did, right? So you got to understand that sometimes, right, when the examiners set papers, right, they do this. They set the first few questions super hard, super technical, super abstract also, right? Just to throw you off, throw your composure off, and see whether or not you can regain composure later. It's also a test of whether you are able to let go of certain things like this, right? It's a thing. I don't make the rules, but this is the thing that I've noticed many years for many batches already, right? It's not just you guys also, the A levels as well. I just had NJC. I just had an NJC paper briefing the other day also, right? They finished the exams as well, right? Most of them did quite okay, but the MCQ was horrendous. It was like 30 questions. 30 questions. Some of them got like what? 12 out of 30, right? 12 out of 30, 10 out of 30. But you know why? Because the first 5 questions were super hard. The first five questions were like worse than this. Was like what? Don't know what math lah, what density, that kind of thing. Do, right? Then I told them, when I first opened the soft copy of the paper, I told them, the first 5 questions I wouldn't do. I'll just go and do 6 onwards. Then down there they stun, huh? I said, what? They're gonna penalize you for not doing in order? Huh? They're gonna penalize you for not doing in order? You gotta understand, sometimes they open the paper with this, they open the paper just to like hung you only, just like scare you a bit only. Right? Then afterwards you lose your composure because the rest of the 25 questions were very doable. So there was one student who actually did that. He was like looking at the first 5 questions and realized, actually very hard. Why? Like very complicated, you know. Then he just didn't do the first 5 questions. Then he went to do the 25. Then he got 25 or 30. Like the rest of the questions were easy. The rest of the questions are easy. So you got to strategize sometimes, okay? All right. Yeah, this one here. State the KE. Woo! Yeah. What's the words that I will highlight here? KE, orbit. KE, orbit.
Sorry, the only
No.
without any conflict.
Yeah, without any calculation.
It's just a part of science. How do we do this?
Actually, a bit unfair also lah. It shouldn't be without any calculation. There is a small calculation, right? You divide it by 2.
Why?
Huh? You halve it. Why? Cause you got to remember. You got to remember. Okay, so the reason why I circle these two things, right, is because I want you to remember orbital energy. I know it's 1 mark only. I know it's 1 mark only. Okay, but it will affect your understanding of the entire thing. Orbital energy, guys. When I say orbital energy, what's the graph that you think of? Orbital. You see? Right, correct, right? Okay, so orbital energy, you think of this graph. This graph. Hey, no. Okay, this graph, sorry, let me just clean it up a bit. Right, orbital energy, you immediately think of this graph. I need a nicer color to use. I use blue. Let's see whether blue works. Think of this graph. Okay, this is energy versus orbital radius. Right, this one, this one, this one. Okay, for those who are looking at this graph and don't recognize the graph, tell me. For those who recognize the graph, tell me what the 3 graphs here. Which one is total?
The one in the middle.
The top one is KE, the one in the middle one is TE, then the bottom one is GPE. Okay, but it's not good enough that you remember the equations because the equations, not good enough that you remember the graph because the graph doesn't help you with this particular question, right? You got to remember the equations. So this one is unfortunate that you have to remember it. So we know GPE is negative GMM over R, right? Is this equation in the data booklet?
Yeah.
It is in the data booklet, right? Right. Let's see, where, suddenly. Yeah, I know. I want to see the others. There's only one of them, right?
Yeah.
Do you have the KE of orbit?
We have the KE.
Yeah. Do you have the equation for KE of orbit? Orbital KE.
No.
It's not available, readily available in the data booklet, right? But do you have velocity of orbit?
Yeah.
You have v orbit, right? Can you somehow half mv squared and find and work out? Can, right?
Sorry, what?
Okay. Data booklet got v orbit, right? Okay, you read out to me what is it? No, from the data booklet. Square root of G M over R. Okay, KE is half mv squared, right?
Yeah.
If I'm trying to find the KE of the orbit, I use the v of the orbit, right? So what happens when you square it? What does the equation look like? What does it look like?
So it's half GMM.
Half GMM over R. Okay, right here, right now. Right here, right now. Since you all didn't remember this, because to me, I remember this. So I want you all to remember also. For orbital energies, GPE is negative GMM over R. KE is half GMM over R. No negative, so it's a positive graph. And it's half the value of the GPE. Okay, it's half the value of the GPE. Which is why they say without any calculation, state the KE, right? I'm just thinking like, that's not really fair. Because I still have to half it, right?
No, wait, I find it's not very fair because they ask us. Because if we have to deduce until this extent, why did they say there's no calculation?
Oh, no, I mean, okay, no, hang on. You're supposed to know this. You're supposed to know the KE is half of the value of GPE and it's positive. That's why the graph is positive. You have to know this. Total energy, give me the equation of total energy. TE, total energy, how much?
GP plus KE.
It'll be negative half GMM over R. Can lock in already or not? Remember this, then I don't have to do D1 for orbital energies already, lock in, right? So just please remember this is the equation, this is the equation, this is the graph, right? Orbital energy. So that was the thing, okay? Right. For now, I'll go to the wait, hang on. Oh yeah, I'll go. Don't have yeah, okay, don't have. I'll go to the SL paper. Hey, HL no rest, because SL whatever SL does, you all have to do also. Okay. Non-uniform E field with field lines shown below exists in the region. No G field, only E field. Okay, fine. Right, there's a lot of repeats now. Okay. What's E field strength? Eh? Wait, did they ask you what's G field strength in the first page and then they... 2 marks. So why do you think got 2 marks? Yes, because you need to add in a small positive test charge. If you don't do that, you lose that 1 mark. Right? So HL, you don't have this, but you got to learn this now. Right? So don't forget, E field strength is right the force per unit charge acting on a small positive test charge. Yeah. No, you're supposed to say force per unit mass.
No, as in, I just want to say small mass. Yeah.
Acting on a small mass in the G field.
Yeah.
You don't have to say that what?
No.
No lah. No lah. What the pong? No lah. Okay, fine.
Yeah.
I don't agree with that. Like G field strength, you don't have to have another mass there. You just need to know how strong the field is, right? You don't have to have a small mass there to have G field strength. You get what I'm saying? That definition don't make sense. Okay, fine. I'll investigate on that one. Okay, but that's why this one here is 2 marks. Okay, this one here, electron is placed here. Draw on the graph. How does the force act on the electron? This one, I think I saw most of you got this right? You all can tell that this is a negative charge here, right? Then this is the electron is also negative, right? So the force will be going this way. Okay, right? This one no problem. Okay, go next one. Replaced by proton. Explain how the motions differ. 3 marks. Walao, 3 marks. What's this? There's a last mark. Wait, electron is replaced by proton. I would think that it will be based on the mass. I would think it's based on the mass. So electron and proton, do they have the same charge? Oh, yeah, okay. They have the same magnitude of charge. Yes, the answer is yes. They have the same magnitude of charge. Okay. So if you place an electron here or proton here, right, will they receive the same amount of force? Will they receive the same amount of force or not? Will they receive the same amount of force? They will receive the same amount of force. Because I'm trying to get you 3 marks. This is a lot of work. Okay? Right. So if it's an electron, then the F equals to QE, right? If it's a proton, I put a proton here, right? Then the F is equals to QE, right? Yeah. And both of them have the same amount of force. Correct? However, they're asking for what? Explain how the motion differs. Right? So the electron will be what? The electron will move to the left. The proton will move to the right. Okay? The electron will move with decreasing acceleration. The proton will move with increasing acceleration. Do you know why? Because the field is getting stronger here. I got one more point for you. I got one more point for you. I'm not done yet. Okay, so number one, right? The force at the instant is the same, so the acceleration at the instant is the same. The electron will move to the left with decreasing acceleration. The proton will move with, oh sorry, the acceleration not the same. Sorry. Backtrack. Okay, one more time. Sorry. Okay, the electron will experience a force. Sorry, the electron will accelerate to the left. The proton will accelerate to the right. The electron will accelerate with decreasing acceleration. The proton will accelerate with increasing acceleration. The initial acceleration of the proton is less than the initial acceleration of the electron because the proton is more massive. Right, so this is QE over mass of proton equals to the acceleration of proton, and this is QE over mass of electron, right, which is equals to acceleration of the electron. Okay? Okay lah. What? Initial acceleration of the proton is less than the initial acceleration of the electron. Because yes, proton is more massive. Right, proton is more massive. So the acceleration is less. I mean, if you tell me there's 3 marks, then okay lah, I'll give you all the 3 marks. But everyone got 2 and then mountain.
The 2 was 80 marks.
2 also, huh?
Everyone got 1, then they exchange into 2. Huh? Oh, you mean really?
2 lah. Crazy if they don't go through the paper and then they expect you to know this. This one? HL go or not? This one? This one HL also, HL, SL. Okay, I go back to HL first. What's this listing the forces? What's this? What's this?
No, they can't translate the definition of
Oh.
so that part was a little bit hard. I find.
Hmm. This one?
Yeah.
What?
Since when do you have that problem?
I just got it. I had to drink more water. Hmm. Okay. This one. Did anybody want me to go through this one? Anybody wants me to go through this one? Yeah? Okay, if you want me to go through this one, oh yeah, okay. Or if you don't need, if nobody needs, then the thing is, if you got this wrong and you still have trouble doing this, just remember, visualize the scenario. Okay, to be honest, I would rather, I mean, I don't need to do this, but I guess the idea is I want you to, right, draw the diagram. How do you accelerate the electron from rest in vacuum, right, with a potential difference of 2100 volts? You do it this way, right? 2100 volts. And then the electron is accelerated this way like that, right? Visualize it. Visualize it. Once you visualize it, this is how the electron is accelerated. Then they ask you find the final speed. Okay? So what is the KE here? Anyone? What is the KE here? Correct. 2100 EV. Right. 2100 leh, not American. Right. So 2100 EV. Right. 2100 electron volts. Okay? Then you can convert it to joules and you convert it to half mv squared if you want, whichever you want. I think more importantly, I want you to understand this picture because this thing, accelerating electron between two plates with a hole in the middle, comes out in a lot of parts in the exams, right? In the entire syllabus actually. Okay, this one. Walao, what's this? Electron in between two plates. Draw force. Force should be pointing up. This is just E fields. Hey, go. Someone asked me how come cannot use left hand rule here, no? Okay? Electron, right? Parallel plates, right? And I'm like, there's no magnetic field. You want to use your left hand rule? Left hand rule has a magnetic field. There's no magnetic field. Not yet. In the next part, yes. I don't know whether because the student went to read ahead and then afterwards got a bit confused and come back to this one, then think have to use left hand rule. No, don't have. This is just E field and electron. Okay? Wow, this one SL also have.
No, I thought Joe making few lines.
Draw electric field lines.
How about
Which, what's with the unfairness here? Why? You're not allowed to draw forces, man. No, both sides draw. E field is pointing where? E field is pointing down. Look at that. E field is pointing down. Okay. Now this is the part where some students can get confused again because they see the E field is pointing down. They see positive plate, negative plate, E field pointing down. Then they see the electron. Then they think that the electron comes in and then the force will also be pointing down. That's wrong. E field direction is dedicated to what? Is dedicated to positive charges, right? The E field direction tells you the positive charge will move where. So this is the electron, the negative charge goes in, force is pointing up. So this one's correct. Correct, right? You got a 1 mark, right?
Wait, no, I don't understand why this
Huh? Okay, I say it another way, okay? Top plate is what charge? Positive, bottom, right? So negative charge. Okay, but the thing is this, right? It's a very common misconception also. Okay, if I tell you that this is E field and I go and put a positive charge inside, I put a positive charge here, proton here like this, right? It will experience a force downwards. If I put an electron inside, okay, naturally it will experience a force upwards, right? Because it's like kind of like because of the two plates. Okay, can? So there you go. Then this one is for SL. SL is just you draw the E field lines. Okay, in a while, I'll give you all something harder to work on.
Huh?
Yeah, I'm going to mix in projectile motion with this one.
No.
Why not? Can be done, what? Okay, calculate the E force on the electron due to the E field. F equals QE straight away, right? F equals QE. That's the first thing. Pum, right? Then E equals to V over D. Pum. Next one already, right? So this one here, I think should be fine. Asa, what you do? What you do? And then you cancel everywhere. It looks like musical notes, you know. Shut up! Why you bend it? Wait, what happened?
I also mixed up velocity or that cancel the end.
It's supposed to be
Oh, okay. No. So yes. This is also a common thing, Right. You all write this, right? E is equals to V over D. Hey, hello. The V is what? This V is voltage, not the speed, You substitute the speed. Walao eh. Okay, so this is the voltage. The voltage 95 volts. This one here. Okay, then the other thing that I think some students get confused by also is the F and the E, right? Okay, F is force. This is force, right? Force is in newtons. That's the force that exerted on the electron. That causes the acceleration. E is what? E field strength. Okay, so don't take the E as the force, right? The E is the E field strength. I think because there were some other versions of the equations that you see in your school's notes. I think there was also another version like that. E equals F over Q. Correct. Same equation, but because of that, I think I saw one other sample paper, right? I think I saw someone write this. F equals E over Q. Okay? It happens. It's an honest mistake. It happens. Okay? Right? I've seen this before. I mean, okay, just in case those who are online don't understand. This is wrong. Okay? But it happens, right? F equals E over Q. This is wrong. Right? But like I say again, it happens. And I think this is also a lesson on its own. You got your data booklet. Please open your data booklet, keep it beside you. I know that there's a tendency to want to do things fast and then you just by instinct you just write things down. Double check your equations. Oh yeah, one more thing. Make it a habit. Write the equation first. Right? Do it like that. Write the equation first before you sub it in. Many times I see students, right, that end up getting a lot of their marks minus off, right, is when they don't write it down like that. They just write the value only. They just sub in the value and then they try to show the final answer. Right? They still get the mark, sure, but that's a bad habit. So good habits wise, write down the equation, double check your equation with data booklet. Okay, make sure it's correct. So sometimes I understand that you need to try and you need to keep on doing it. You need to keep on doing it up to the point whereby you won't write this wrongly. You get what I'm saying? Right? Like you won't write this thing wrongly. So you just have to yeah. But there's like 25 chapters to practice. So that's a lot. I get it. HL also have this one, right? So what is this then? Oh, this is something extra that SLs don't have. Okay, this thing here. Wow, this one. Okay. So now they tell you that there's a magnetic field. So you have an E field, then they add in a B field. Trigger, this is velocity selector already. But you know what? IB doesn't like to give names to it. Your school also don't like to give names to it. I like to give a name to it. I like to put a label on it. This concept is velocity selector. Right? Immediately, right? Velocity selector. This one here is the E and B cross. Okay? So these are electric fields and magnetic fields cross fields. Okay? Then they tell you that it still goes straight through the horizontal metal plates. That means it's undeflected. Undeflected. Alright. Then this you use a left hand rule. Or was it that the person who was asking me the left hand rule? Was it asking here? Are you supposed you're supposed to use the left hand rule here. Right? To the person who was asking, right, whether or not you're supposed to use the left hand rule, you're supposed to use it here, not the previous page. You're supposed to use it here. Okay? Whew. Right. Right. To see this, right, you know what? I'm gonna draw a fresh one. Right, I'm gonna draw a fresh one. Hang on, Right. So down here, this is plus charge, right? At the top, minus charge at the bottom. Electron fly through, okay? Then they ask you, how should the magnetic field be pointing? You only got two options. It's either pointing in or pointing out, okay? So therefore, if you recognize that this was velocity selector, you recognize that this was the thing that I did in, where was it? D3. If you recognize that this was in D3, okay? Right, this was D3. This is towards the end of D3. Yeah. D, right? Yeah, D3, okay? This was the electric force. They tell you that the electron flies through undeflected. That means it's continue flying through like this. We have to infer that the magnetic force is pointing down. Right? Hey, SL also listen, this one. Yeah. Sorry, this one. You all do charge particle forces, right? Charge particle. You do, right? Yeah. Why did they take it out from your test? You should be inside your thing. Yeah. You should be inside your thing. So you all gotta pay attention now. Okay, one more time. The idea is the electron managed to pass through undeflected. Okay? Right. Is it supposed to pass through undeflected if there was only electric field? No. If there was electric field, it will do projectile motion and hit the plate, or maybe escape somewhere. Right? But because they say that they apply a B field and the electron continues to go straight, which means we have to infer that the magnetic force is pointing down. Okay? Left hand rule. Here's the important thing. Electron, this teacher also damn funny. This teacher like do a double layer trick. Yeah. Electron, right? Current's pointing to the left. Your current is pointing to the left. So your force must be pointing down. Your current must be pointing to the left. Right, and when you do it, then therefore you know that the magnetic field points into the page. The field must point into the page. So you have to draw magnetic field crosses everywhere in this region. Okay? Electron pointing, electron going towards the right, current points left. Make sure your middle finger points towards the left side. Okay? And the force points down. Right, so naturally your finger will align like that. Your index finger, your first finger will be pointing into the page. That's the magnetic field. Right, that's your B. This is your E. But it's not so simple like that. There's also another caveat, another condition for the electron to go through undeflected. What's the other condition for it to go through undeflected? What? mg is not considered for particle motion. No, it's not that. Mg is negligible. I mean, good point, but when we talk about charged particles, when we talk about electrons, Mg is ignored, so we don't use it. When do we consider Mg? Oil droplet. Millikan's oil drop experiment, you have to consider Mg. This one don't need, so don't go add in the Mg. Okay? So the caveat for this one basically is the velocity. So Fe, right, equals to Fb. Right, what's the equation for Fe? QE, what's the equation for Fb? Right, BQV or QVB, right? And then the Q will cancel off. Right, so the caveat is it must meet this ratio. That means it just so happens that the electron has the correct V, that is the correct ratio of E to B, so that it will pass through undeflected because the forces balance. Right? Do you all get this one?
Okay, so you only get like you get part 3 correct if you get part 3 wrong, you get the first one.
Yeah. So this is a little bit unfair. I mean, I was looking at the paper and I was like thinking, you are riding on a lot of marks from the first part, you know? Yeah. Like that's not quite IB style also, to be honest. Huh? What, sorry? Yeah, it should be. They should be error carry forward, but it's very hard to give error carry forward for a binary thing. It's like you only have two options, either in or out, right? Yeah. So I would say that the way the question is set is not the best, right? Because you basically would have a lot of things riding on. Yeah. Anyway, they want you to find the B, so your job is to do the just like that, V equals to E over B, right? And then find B. Can already. Can? Okay. Right, you got V, right? They give you V, right? What V is this? Velocity, Don't go and put voltage, please, Yes, small v, small v, small v, okay, small v, right, small v, okay, small v. Then big V, right, is voltage. Okay, now scenario time. Side quest. Okay, we're gonna do a side quest. Side quest. Right, I'm gonna try to make it look very hard for you. Okay lah, don't make it too hard lah. Okay, tell me what's gonna happen to the electron. Projectile motion, right? So it's literally projectile motion, but you have to explain to me why is it projectile motion.
Something about something constant.
Because of horizontal acceleration is constant.
Yeah, hearing all cross talk. It's like this one wrong, that one also wrong, but I didn't hear this one.
Horizontal.
Correct.
Acceleration.
And then this one trying to define projectile motion, which is great. Yeah. Okay, can. So you all draw this in first. You all draw. I still want you all to draw. You all better draw this in.
We are finishing this today. Yes, yeah. Still side quest.
Still side quest. Wow, you asked me still side quest. Walao. Okay, I know you all want to get to this point. I know where you all want to get to. You want to get to the binding energy, right? Huh? The binding energy, right? You want me to send you all the recordings that I told you to pay attention to the binding energy, right? Every one of you, I tell you, skip. Okay, so no matter what, I still want you all to know this because whatever it is, right? Here's the thing, guys. Whatever came out at CT is not going to come out in your your prelims. You get what I'm saying? It's not going to come out in your prelims. So I'm trying to think of other scenarios for you to understand. Yes, one thing you learn what your paper has tested you. That's why I'm doing a bit of a side quest. Can? Yeah, actually I shouldn't draw the force like that. It's so weird. Okay, Okay. Oh. Okay. Oh, okay. Okay, so the force is acting downwards like this. The force is acting downwards like this. Okay? So Keegan was trying to define, right, the projectile motion. What's the definition of projectile motion, Keegan? What? Hey, constant velocity in one direction, constant acceleration in the perpendicular direction. You're not allowed to say other directions. Because other means the other direction. Perpendicular direction, okay? So the idea here is this. Which one is constant here, guys? Horizontal is constant. So this guy here is a constant horizontal velocity, right? And this force, the downward force gives you what? What does the downward force give you? Is it constant? It's constant, right? Constant, right? Constant vertical downwards acceleration. Right, so that's why this is a projectile motion. I mean, I'm not surprised if this comes out. Anyway, your prelims also have like the legit projectile motion. I haven't seen a projectile motion come out for your exams in the longest time, right? You could also get a weird scenario. This is from the IB, You could get a weird scenario like this. There's a ramp here like that, right? There's a ramp here like this, and they project a marble. They project a marble like this way, then it goes like that. Yeah, that's projectile motion also. Because the slope component is the constant acceleration down. So the projectile motion path is like this. Okay, this was an actual IB question from quite a while ago. Okay? What was up?
A equals to G here.
Nay. What? No, nay, no.
What is A equals to?
A is caused by the electric force.
Oh.
So QE, what did terms like? Oh, QE goes to M electron A. This is an electron, right? I mean F equals to MA,
Oh,
right? So A is equals to QE over mass of electron. Okay?
So in
Right.
this case, do we
Wait. No, I know. Wait, right? Okay. You cannot say that A is G. If you say acceleration is G, you're suggesting that there's gravitational acceleration. But the electron's weight is so small that the gravitational acceleration is actually negligible. So we only consider the electric force and the acceleration due to the electric force. Okay? This one here is slope projectile motion. This one here, actually the acceleration is A sine theta. G sine theta, sorry. This one, the acceleration is equal to G sine theta. I can do this another day, but for now, just remember that if you see a weird example like this, right, then this is what happens. Right, I'm going to try to pull out the question for you guys. Right, seems like projectile motion might be a bit. Not that I don't think you can do. It's just that we haven't done projectile motion in a damn long time. Did I even do that for revision? I didn't even do that for revision. Did I even do kinematic for revision? I haven't not done. Did I? Did I do A2? I did forces. Okay. I didn't do A1. I didn't do A1. Okay. I have to do A1 at some point. Okay. So we have to do that. Okay, next one. Okay, so this one here. Why got one tick and got one cross one? No arrow. Walao eh. Wait. Why no arrow one? Magnetic field must have arrow. Like racetrack like that. Peanut, yes. Eh, cannot lah. Why this big fella so mean? 你得罪谁? Huh? No, he forgot to draw the small circles around it. Yeah. You all got the small circles around it. Yeah, okay what? You see, this one inconsistent marking. This side really counting. You see, his one is correct. Huh? Hey, go ask him. Never mind lah, so lah, just beat them in the prelims ah. Okay, hey, this one yo.
Yeah, wait, also about that.
Huh? I don't know. I don't know. This one here.
Minus 5. My God. How did I not get minus 5?
Wait, this chapter is what
Oh, why minus 2?
Wait.
Why you 0.01? This 0.1.
Because they give
Oh yeah.
NCM.
It's under HLSL. Yeah, this one. Hey, this one just plug in equation, yeah, right? Wait. Yeah, okay. Your sister calling you.
Yeah.
Okay. Why is this wrong? You forgot the what? No what? But 0.1 what? 0.1 meters, right? Is that not right?
0.00. Wait, I don't know how.
How can you?
But it's not 10. Minus 2 C is
This 0.1.
So that means E right?
Yes. Oh, yeah, that's true.
Yeah,
It's
it's
no, that's it. No, it's just 30% more. Hey, your patient is
but it's good.
What happened?
No.
What's wrong?
It's fine.
This one, I actually I like the double. I need the double share.
It's okay to give it. That's not
Shit.
Yeah, I don't get it though. I don't get it. Wait, I don't get it. Isn't this the correct answer? It's the correct answer what? It's correct answer what? 3 times 10 to the power minus lah, the minus sign disappear lah. The minus sign disappear lah. Hey, open your eyes, open your eyes. Yo, you also. Calculator, why your calculator show you non-standard standard form?
It's like that.
No, standard form supposed to give you 3.01. Why your standard form be standard one?
How do you say it?
I don't know.
I don't know.
I also don't know. Hey, someone show him how to make the standard form a bit more standard.
No, it's 30. 30.
You also get 30. What kind of stupid calculator thing is this? No.
It's 3.0.
Hey, this one you all cannot get this wrong. The two wires in the same direction is pointing towards each other. I went through this so many times. Why? I don't get it. I don't get it. Original lesson, I went to look at my original lesson. I thought I missed it, you know. Original lesson, I went to look at the revision lesson. I got say both, you know. Cannot get it wrong. Cannot. That's why somebody only got two things only. Wait. Okay, here's the thing. Some students thought, with regards to this from previous batches, some students thought that they had to work it out from scratch. I said, I think in the lesson I said, no, please memorize that same direction, attract, opposite direction, then repel, right? And I don't like to use the word attract and repel, right? It's either they point towards each other or point away from each other. Okay? Someone write correct answer, cancel write wrong answer. Then deviate again. This is what? What's this? This D4, this D4. Okay, this SL, this HL. Okay, HL. This one. This one, it cannot. I tell you, this one also another one. Okay, this one, I send video. Actually, I just did this with my year 4s also. This one I'll send video. Don't need D4. Okay, you want to play who? What you want to play? You forget! Okay, now here's the thing. I know it's confusing. Okay, let me show you where the confusion is. What's the flux when it's vertical like that? What's the flux? Guys, D4, HL. What is the flux when the coil is vertical like this? It's maximum flux. Right? The flux is maximum. Why? Because, actually it's a very badly drawn diagram also. My gosh. You can find much better pictures online, right? Okay? You have a coil like that, right? I just try to replicate lah. The amount of flux that's going through, right? Going through the coil is maximum. Okay? Right? But the change in flux, because they're talking about induced EMF, right? Induced EMF, but the change in flux is 0. So flux here is equals to max, but the change in flux is equals to 0. Okay? So, yeah, there you go. Now, but I don't know what's the acceptable answer for this. I'm not too sure what the acceptable answer is for actually, I'm not too sure what the acceptable answer for these 3 marks. Okay, I would write it like that. I would write it that when it's vertical, the rate of change of flux is 0. Therefore, the induced EMF is 0. When it's horizontal, rate of change of flux is maximum. Right. Therefore, the induced EMF is maximum. But it sounds like I'm not gonna get a full credit for it.
I wrote the actual answer.
Did they talk about perpendicular force? Yeah, they talk about perpendicular force. Okay. So it's the same way I did it with my Sec 4 students just like today actually. Okay, right, let me just go through this very quickly before I get to binding energy. I know you're all desperate to get to binding energy. I also want to go home and eat dinner. Right, this is a magnetic field, right? Magnetic field. Okay, the coil is like that. Okay, so what position is this when the coil is like that?
1.
Huh? What? Oh, position 1. Yeah. Okay, but it's vertical, right? Good. Right. But we are applying force on the edges of the coil. So we are applying a force here and we are applying a force here, right? Why are we applying the force? Why are we trying to apply the force? Because we're trying to generate electricity. Right? We're applying the force. This is not DC motor. Do you mistake this for DC motor? Brother, this is D4 electromagnetic induction. Okay. So this okay. I mean, if you're drawing this now, you better write down. This is the applied force. Right? This is the applied force because we are applying a force in order to generate electricity. We're trying to generate electricity. You get it? Okay. So right here, right now, look at the direction of the force and the field. They are direction of force and the field. They're parallel, right? One points to the right, one points to the left, but it's parallel to the magnetic field. So when the force is parallel to the field, no EMF is generated. EMF is only generated when the force applied is perpendicular. When it's perpendicular to the field, then you can get your induced EMF. If your force and field are parallel, Jethro, force and then this yeah. When the applied force and the field is parallel, that means they're both pointing towards the right side. What's the induced EMF? Is current? Zero, nothing. The right hand rule can only work if the fingers are perpendicular to each other. Okay? 10? Okay, good. What?
This is the right hand rule. Yeah.
What's
This
one?
one.
Yes, it is. Oi, brother. Hang on, let me just. Okay, I'm gonna have to show it to you explicitly. Okay, hang on. Okay, so what happens when the coil is horizontal? Okay, when it's horizontal, the applied force will be wait. Okay, right? The applied force will be right down here like this. Okay, so you see this, when the force is perpendicular to the field, then you'll get your maximum induced EMF. Any other angle will be less than perpendicular. Less than perpendicular means that it will be a lesser induced EMF. This is the max. What's the maximum induced EMF equation? SL don't need. Maximum induced EMF. Vmax equals what? I went through this before. Yes, this is not in data booklet. Yes, it requires you to memorize it, right? It's a bonus mark. If you can memorize it, try to get a bonus mark. Vmax is for rotating coil. Anyone? Women's basketball. WNBA. Okay, that's the maximum voltage. Right, omega is okay, good. Okay. Omega is the frequency of rotation. NBA is the number of turns, B is the flux, and A is the area. A is this area. A for area. Okay, let's go on to the next one. Yeah, this one they're trying to trick you this one. Number of turns of the coil. So right now you see this picture, right? This looks like it's a 1-turn coil, right? Okay, but if your coil looks like this, so you wrap many times around like that. Okay, it looks like this. No, take.
Oh my god.
Take.
Dust.
Got smell on me, dust. Okay, Ken. No, I just took it out to use only. Oh, yo, what's this? Wait. This one okay, this graph okay or not?
Shape.
Oh, because you have to start from.
No, you see, right? The problem is that
You have to start from cosine. You have to start from max.
if you think it's position 1, right, you will start from 0. If you think it's position 2, then you will start from max.
No. So they're saying that this is t equals to 0.
know.
Yeah. What they're trying to do is the teacher is trying to play tricks on you. Because they're trying to make you feel that flux linkage is 0, so you start from 0. Then they minus 1 mark from you. This one, okay lah. This one the teacher successfully trick. If they trick you, they manage to trick you lah. But you gotta learn how not to be tricked. So horizontal position, maximum induced EMF, you start with max, so it becomes a cosine curve. That's why the shape lose 1 mark, right? But the rest of it is correct. Okay, don't let your teacher take your marks from you. Right, especially, you know, okay lah. Maybe not this rotation, still not so bad. Well, next rotation, teachers I do go fight marks with them. Hey, this one SL got or not? This one have, right?
Yes.
Ah.
Oh,
I don't. I also don't know. I see the blank one. I see the blank version. Keegan, chill lah, Keegan. Hey, don't like that. People embarrassed already now. Longest wavelength. Longest wavelength means lowest energy. Longest wavelength. Cannot. I don't know how else to tell you all. I repeat many times already. Okay, but here's the thing. Okay, what a common mistake the students make here. They think wavelength has something to do with electron. Okay, so at some point, after all the E's that we went through, right? E1, E2, right? Then it's like, wow, then confusing, right? Then electron, right? This is electron, right? Then got wavelength. Then some students ask me, oh, is this something to do with the Broglie wavelength? No. Huh? Oh yeah, you cannot. Okay, like something to do with the de Broglie wavelength, right? They get confused. So de Broglie wavelength is when the electron behave like a wave. This is not it. This is the electron jumping up and down, right? Absorbing energy and emitting energy. It emits energy as a photon when it jumps down. So as it jumps down, it emits a photon. So the question is asking you for what's the longest wavelength photon. You have to recognize that wavelength is associated with light. Light is associated with photons. Wait, okay. So you are looking for the smallest energy one. Go. Smallest energy one. Okay. Locate the camera. Okay. Walao, this one just choose the smallest one can already. What's the smallest one? This one ah? Yeah. This one oh? This one gives you your longest wavelength photon.
wait, sir.
Okay. Wait, hold on. Do you understand the what? Okay, put yourself in the teacher's mind. Now you think about it. Do you know why he said this question? Because he's trying to trick you. He's trying to trick you into thinking that longest wavelength, right? You see the word longest, right? Then you'll be thinking of like, oh, what is the longest one? Okay? So you have to always remember the teachers are always out to give you terms to contradict. Right? You realize that this has been happening since question 1. Give you the distance from the surface. Right? Then give you electron current pointing backwards. Okay, so you really have to kind of be firm with your fundamentals. Yes, Keegan.
Are photons only visible light?
Huh? What?
Are photons only visible light?
No, it's not.
So it can be like non-visible.
Any EM radiation is photon. So during my lesson, right? Okay, instead of saying EM radiation, I say light. Do you know why? Cause many syllables. EM radiation. Wow, I say until my tongue will fall off. Right? So I just say light. But when I say light, it could be radio wave. Okay, to be honest, this thing here, this photon here, the photon that's emitted here, this is a radio wave. This is a radio wave photon. Eh? You mean they ask you to calculate?
No, because the number come out, it's kind of feel the.
Oh wait, they ask you to calculate the wavelength? Oh yeah. Oh sorry. Yeah, what was this? Yeah, they ask you to. Oh, I thought they just want you to. Oh, so you have to do two things. You have to label the arrow and then calculate the wavelength. So this transition, right, is equals to hc over lambda, right? So you need energy change and then equate to the lambda. What's the lambda?
1.91
times 10 to the power of 6.
What is this?
1.91
The word, the weird
micrometer. You mean you write it down, you don't even recognize it yourself? You deserve the mark, or you think,
Maybe.
You write it.
The back there, then I was like, yeah.
Hey, no, this one not radio wave, this one.
This is what?
This one not radio wave. What's this?
This IR.
This infrared.
What?
1.91 times 10 to the power minus 6. That's infrared. Sorry, this is infrared. Yeah, this is infrared. Yeah.
How does it appear in the spectrum?
How does it appear on what spectrum?
The absorption, emission.
Are you looking at the visible spectrum? Okay, hang on. Okay. You remember this spectrum? Right? This, I mean, if you can see the colors, this is visible spectrum. Anything beyond here is what?
Invisible.
This is a UV, X-ray, gamma. Anything beyond here? Infrared, microwave, radio waves. So if you ask me how does it appear on the spectrum, I can't describe it to you, right? Unless it's a computer image.
Okay.
Unless it's a computer graphic that shows you where the lines are down there. But visually, I cannot describe to you.
Okay.
You know, like these are the colors that humans can see. These are the colors that, mantis shrimp can see.
Really?
What the?
They see other colors.
They see other colors. They can see UV and infrared.
What are they?
But I can't see it, so I can't describe it to you. Huh? I'm not a mantis shrimp. Continue. Oh, the next one is binding energy. Closest approach. Wow, Pyang, did I not do closest approach? I got do or not? I got do, right? 3 methods of. Okay, but I think the worst thing is that during the June holidays, I did mention you have to pay very close attention to the charge. Did this one pay close attention to the charge? Hey, Q1, Q2, correct what? Where? Oh. Then you got it. Oh, okay. But this one correct what? Q1, Q2, right? You took 2 times 82 times 1.6 times 10 to the power minus 19 squared. Because that was exactly the thing I told you all to be careful of, right? But okay, this one okay. You asked for video. I went through 2 times. I went through in lesson and I went through in June revision. Lead nucleus. What's the charge? $82 protons. Positive? Nucleus only. Known electrons. Nucleus positive. 82 protons. 82 times 1.6 times 10 to the power minus 19. Alpha particle. Nucleus. What's the charge? 2 times 1.6 times 10 to the power minus 19. I give the alpha particle some initial Ke. So it will fly. Will it come to a stop? Why?
Because positive.
Correct, right? So it will come to a stop. But what happens after that? It will fly backwards, right? So your job here is to calculate how close it gets to. Right? So what's the equation that you use to help you calculate that distance of how close it can get to? Ke equals to EPE.
Oh.
Get it now? You take the Ke, you convert it to EPE. That's why I went through in June. You were not here in June, is it? Okay. Okay, this one. This one, what is it? This one. This one I couldn't figure it out. This one. Rutherford scattering, I know I did it, but then they're asking why is there no deviations in B part 1. Oh, you're supposed to compare the distance from here to here, is it? Okay, so how does this one the teacher damn tricky. This one is confirmed tricky. Okay, this one is tricky. This one is confirmed tricky. Okay, how does deviation occur? What's the alpha particle, HL, what's the alpha particle supposed to do when it go past the nucleus? It's supposed to deflect, right? Huh? No, it's supposed to deflect, right? So then I give this guy more energy, more and more and more energy, correct? But at some point, the alpha particle has so much energy, what happens? It gets so close that it touches. Then once it touches, what happens? Strong force. Strong force and doesn't deviate anymore, doesn't deflect anymore. Okay? The question is asking you, why is there no deviations? So the deviation occurs when? The deviation occurs when what? One more time. The deviation occurs when the alpha particle is too close until it touch. So how do you not get deviation? Don't be so close lah. Right, stay further away lah. Right, so the question is this. What's the answer here for the first part? What's the proper answer? 4 times 10 to the power of minus 40 meters. Okay, so the alpha particle can at most reach, right, be this far away from the nucleus at a distance of 4 times 10 to the power of minus 40 meters. You understand this? Okay. The size of the nucleus is 7 times 10 to the power of minus 15 meters. So does the alpha particle get close enough for deviation to happen? No, that's the answer. The alpha particle was not able to get close enough to the surface of the nucleus. Strong force doesn't occur, deviation doesn't occur. This is very technical. Okay? So whoever's paper I commented for this question here, I'm taking back, this is a very technical question. I mean, if you lose these 2 marks, I want no choice. But this one you should get. Oh. Yeah, okay. Okay, just have to get the frog out of it. Right, so this one here is basically the nucleus is very small. The nucleus size is this one here. Like, let me show it to you here on my board. This is 7 times 10 to the power minus 15. So the idea here is that the alpha particle is not close enough. So you got to remember what causes deviations. This one here requires a very, you really have to remember that deviation is caused by getting too close and strong force happens. Strong force happens, then therefore there's deviations. So if you don't want deviations, basically the alpha particle is never close enough, right? That means the alpha particle does not have enough initial Ke to get close. Okay. Wow, this one. Okay, I tell you what, I do the BE now. Okay. So HL has another whole range of photoelectric effect questions. Right, I think at this point I have to kind of like skip it a bit. All right, but oh my gosh, this thing, right? This was what I was doing in the June revision. Okay, so this one here you have to state that the electron does diffraction. It has a diffraction pattern, so therefore electron behaves like a wave. Right, this is the first answer. There's a first minimum, right? There's a first minimum. And this one, oh my gosh, this one, the density of the nucleus, this one. Right, I was showing you how to calculate, right? Density equals to mass over volume, right? Please.
Wait, but can I just say that, actually Shamina said that
Hang on, Laura. What?
I got my 1 mark deducted just because I have to you. I don't know why. I don't know why.
Yeah, but then you saw I was doing also, I put mass is AU ma. You have to remember to put
It's
AU. Like what does A times U stand for? Total mass of the nucleus. That one no choice, that one I agree. That one you cannot not have the U there. You must have the U there. Okay? Sorry, Laura, what? No lah. Yeah. No. The idea here is that the electron classically is known to be matter, to be particles. So they are trying to ask you, why does the experiment show that the electron behave like a wave? So the answer is only strictly just based on the wave only. Like we don't have to dispute whether the electron is a particle. We know electrons are particles. The question is, like, how come the experiment shows that the electron is behaving like a wave? Okay, yeah. So this one is diffraction, first minimum, right? There's a minimum intensity indicating that there's superposition, destructive interference, right? Therefore, the electron behaves like a wave, right? Because of all those things, right? You like what's wave theory? Wave theory. When we say wave theory, diffraction, interference, superposition, constructive interference, destructive interference. These are all words for waves. So to show you that electrons are doing this sort of thing means to show you that the electron is behaving like a wave, right? Anyway, that's the answer for this one. Okay, this one here. Did you get it at the end? You didn't finish up. This one didn't finish up. You have to finish up. Why left it there? Oi. Okay. Go and get it done again. Go and do your corrections. Okay. Are we finally here? Yeah, we're finally here. What? Here's Mark. Alamak, you sent me also sideways. Someone's supposed to see it.
Oh my.
I cannot flip it in water. I told you already. That's why I always ask you all to send it upright. No, hey, you confirm this one, same problem. You all don't put the U down, right? Then you all just put the A down. A is mass number, bro. It's not the actual mass. They want the actual mass divided by the actual volume, bro. You take you A only, right? You're not showing the total mass of the nucleus. It has to be A times U. Cannot. Also agree. 1 mark gone. Who? Sorry, what mark? One more time. A is the mass number of the nucleus. A times U is the actual total mass of the nucleus. You hear what I said? Write it down and figure it out later. Can? A is the mass number of the nucleus. A times U is the mass of the nucleus. You got that? Written it down. I'll figure it out with you later, but please write that down first. That's like the most important thing for now. Okay? Right? Because U is like the average mass of each nucleon inside the nucleus. So when you take A times it, that's the total mass of the nucleus. Yep. Who's this? What's this about? What's this? No. 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 Just no. No way. You didn't even show what mass is. You just put mass. You didn't even show the A times U. No. What? Below? No. Why? Because you're not using the standard variables. You're not using the standard letters. I don't like it. No. Let me see first. I don't understand why you put R3 as a subject here. Like, what's up with this? What are you trying to do? We're trying to show the density is the same, right? Why do you put R cube? For what? What's that? I don't get it. Okay. What's the objective of this question? We're trying to show that the density of all nuclei is the same, right? Okay, that's it. Can we just work on trying to show that density of the nuclei is the same without trying to interpret it in our own other way, trying to say that, oh, if I want to show that density is the same for all nuclei, I show it by showing that the volume is proportional to the density or something. I don't know what you're trying to show here. Make rho the subject, make the density the subject. You don't put R cube there. I don't get it. Okay, finally this one. I cannot believe how many, like very so few of you. In fact, all the 70 plus, you got 70 plus, but it's because you lost marks here. Why? I don't get it. Okay. Wait Is it the wrong question? The first one. The second. This one. Binding energy per nucleon. Okay. I had one brilliant one. What did the fellow do?
This
No. It was no. I'm not being sarcastic. It was actually something that, like, if you work backwards, it actually works.
What?
Yeah. You know why? Because the question didn't state, right? Starting from constituent nucleons. They should have said that. IB will tell you that. IB will say, starting from constituent nucleons, calculate the binding per energy per nucleon. No lah, this one do the same thing also, this one. The fellow went to take this, right, and then completely change it to energy. And then went to do and divide it by 4. That's still wrong, actually. Yeah. Okay, wait, hold on. What do you think you're supposed to do here? I think that's the most important thing. What do you think you're supposed to do here? Huh? You're supposed to, yeah, I mean, because I just said it, right? Because I said starting from constituent nucleus, sorry. Yeah, and maybe I shouldn't say that. But yeah, guys, okay, you're supposed to start with 2 protons plus 2 neutrons gives you helium 4 2. Okay? Then the question is, where do you get the protons and neutrons mass from? Data booklet. It's all in the data booklet. So you're supposed to do this. Okay, now I understand because this one is already very late in the paper already. This is like past the midway point already. You're shacked already. Your brain worked out already, okay? Alright. I understand. If you lose this one, I think that's still okay. Alright. Because it does sound a bit out of context as well. Technically, you can also work it the other way around. But no lah, yeah. You're supposed to find the mass effect. You need to find the del mass. Right? The total mass on this side and the mass on this side. Find the del mass. Then del mass times 931.5 MeV, then afterwards divided by 4 nucleons. Then that's your BE per A. Okay now. Wow. What happened? Why? Wow, this one question really, wow, the teacher must be damn happy. This one question, right? He managed to catch all of you. Huh? Who?
Yeah.
Who? She's the one who said this one.
She might be the
No. His question is who set it. Is it? Is it him? I don't think so. He old already. I don't think he set papers on. Okay, but what I do think is that this question should have said, considering the constituent nucleons. They should have said that, because this will be a very abstract for an IB exam. Considering constituent nucleons. Okay? Right, that should be the question. That should be the way the question is asked. This is not very fair to just throw in on students like this. Okay, fine. Right, but you all got caught. Okay, it's fine. Right, get caught. Don't get caught second time. This is the first time you're doing this topic also. Right, this is the first time you're doing this topic for test as well. Test you second time, you're better than don't get caught already. Right, once bitten, twice shy. Hey! This is mass defect also, right? This one, calculate the mass here, calculate mass there, right? Wait, did you all forget to add the neutrons mass? Is it because you all didn't add the neutrons mass? Yeah lah. You need to add the neutrons mass. Yeah, I use red. Oh, angry oh. You need to minus away the neutron's mass. Ay. So the thing is this, guys. This sort of working, right? You look at it, right? The concept is there. The concept is there. Okay? So for this kind of situations, I would say still safe. Still safe. If you have no idea what's going on, then there's a bit of concern. Then of course, we have to go and fix it. But this one is just you forgot to minus away the mass of the neutron. I think I know why, I think I know why. I think I know why you all forget to minus away the mass of neutron. Because they start off with BE then, right? Then you all look at this, right? Then you all might be thinking, the neutron have no BE. Like you subconsciously you know that when I was teaching you this, right? When I was teaching all of you this, right? I told you that if you have to consider, there's two types of calculations, right? Wait. There are two types of calculations, right? What's the first type? Checking the mass defect, correct? Second type of calculations, checking the total BE, right? The total binding energy. And I think that in your head you probably got it mixed up and then thought that, oh, when you have a neutron, right? You can ignore it because the neutron has no BE, which is true, but you cannot because this question is about the mass. So you have to include the mass into it. But why? I mean, it's just one error, right? Why the whole thing gone? Yeah, it's just one error. Okay, next one. Suggest with reason which one is more. I'm very surprised by this. Hey, hello. How come your okay? What is yeah? What are some of the answers that you guys have?
I say one more proton, so it's bigger electricity.
Wow, we're gonna throw this bottle at you. Anyhow, wet. Okay, there's a few things that you can say. Okay, right? It's a decay. Hey, wait, hold on. Someone sent me this. And the fella got marked wrong. I don't agree. So the person who sent me this other version said that it's a decay, it's a spontaneous decay, right? I think he said something like the products are more stable than the reactants, right? So having more stable products means greater binding energy. That one is the correct answer. So I don't know.
So that's the correct answer.
That's the correct answer. Then why did the fella get marked wrong?
Most people reply and gives choice to release a message.
Oh no, I better go and look at it again. But yeah, okay. Decay is spontaneous, so we can immediately assume that Y is more stable than SR. A more stable nuclide has higher binding energy. A more stable nuclide has higher binding energy.
Can you explain why it's more stable?
Huh?
Like, why is it more stable?
Don't need. Why you go an extra one proton?
So why is it more stable?
Huh?
So why is it more stable?
Energy is greater.
No, because decay always results in that the
Why does decay result in more stable?
Bishan, I don't know how to answer you, no. As in, I really don't know how to answer you. Like, I mean, it's the idea that, okay, the decay happens because it wasn't stable. So in order for it to do whatever it does, or what's the next thing that happens with it, it decays and then it becomes more stable.
Okay.
That's the rationale behind it. Any other versions that anybody write, and then any other one with a different version of this? Okay, that's fine. Okay, let's try to finish this part up. State the change in strontium-90 nucleus following the radioactive decay. So this one is one neutron, like convert, right? Become one proton, right? Yeah. But that's it, all. You can also throw in and say that the electron and neutrino, anti-neutrino got emitted, but that's not what happens inside the nucleus, right? They ask you what's the change in the nucleus, right? But it's one mark, no. Random and spontaneous, anyone? Random is what? No particular order, right, of decay, but there is a constant probability of decay amongst all nuclei. Eh? That's not an answer key.
No,
Wait, can you see whether this answer is
Cannot be predicted.
what this answer is?
There's no fix because not enough.
Not enough.
Yeah, they have to random is what? No fixed order.
That's unpredictable.
It's unpredictable, is it?
Yeah.
Oh, okay. No, that you should also. I mean, the official one should be there's a constant probability of decay
Wait,
for all nuclei.
I
Yeah.
thought there's no fixed method to predict when the decay will take place.
Trisha, is that you? You got marked wrong for writing constant probability of decay. No. IB will accept it because that's the official spawn. Oh, that's what random means. I see. You see, I tell you already. You all the teachers all inconsistent marking one. Mark wrote something, Trisha wrote something, both of them got different marks. Sorry, Jethro, you wanna ask what?
I wrote that there was no fixed method to predict when the decay phase.
There's no fixed method to predict. That's not random. That's saying that you don't have the ability to predict. Right? It's just we're saying that the particles are not predictable. Right? You actually imply that there's a certain way to predict it. Spontaneous. Hey, spontaneous. Not affected by external factors, yeah? Right, will happen. Yeah, basically no spontaneous, all you have to say is no external factors can affect it. That's it. Don't have to override or anything like that. Okay? Okay, next one. What is this the one?
Teacher got one more.
HL got one more part. Was it? Oh, you keep sending me stuff. What do you want? Wait Yeah. Okay, I'll look at it later. This one is it? Half-life is it? At the time of purchase, its activity is 3.7 times 10 to the power of 6 becquerels, the initial number of atoms. This one is just math and manipulation, right? They want you to find n naught, right? This is a naught, isn't it? This is a naught, there's n naught. Okay? They give you half-life T half, right? This is just purely mathematical manipulation, right? You're supposed to go and link these three things together. So a naught equals to lambda n naught, but we don't have lambda. How do we find lambda? Lambda is T half equals to ln 2 over lambda, right? And then you just work it all out. Oh, annoying. You have to convert it to years, or you have to convert it to seconds. Wow, these people are damn freaking annoying. Wow, seriously, every question one trick, you know. Almost every question got one trick. Like this is that one thing also. So you see, right? The T half will follow the time unit of the lambda. The lambda will follow the time unit of the T half. If you use T half in years, then when you plug the lambda inside here, you need to convert your A naught into years, or you convert your lambda into seconds. Right, because becquerels is per seconds. What? Every question one trick. This fellow who set the paper. Good. No, never mind. Good. Okay. Prelims, you get back at them. Wow. This whoever said this, go find out who this teacher is. Wow. Every single question there got one extra trick, you know. Right. But I mean, trying to calculate this already is hard enough. Right? Still want to make students go and convert it to seconds or years. Yeah lah, that's why you have to make sure the time factor is the same. Okay.
Wait, so I don't understand.
Yes.
The second thing.
Okay. This one will take a while, but I'll tell you that. Especially for these two equations, when it's like that, right? Okay. The T half is in years, right? The T half is in years. So when you flip it around and you get lambda equals to ln 2 over T half, can you tell me what's this value? Quick on. Just tell me. In years, yes.
You get 0.025.
0.025, 023 per year. Okay? So what this value is telling you that the probability that the nuclei decays in the next 1 year is only 0.025. The probability. Okay? when you take the probability of decay and you multiply it to the initial number of undecayed nuclei, so n naught is the number of undecayed nuclei, you will get the activity, which is like, how much of them are decaying, right? It's like the probability of decay multiplied by those who haven't decayed yet, right? That will tell you how much are decaying at that unit time. But if you sub in lambda with the year here into this, we are calculating activity in terms of per year. How many decays you get per year? But the information given to you is becquerels. What is becquerels? Becquerels per second. So you convert the becquerels to per year, or you convert the year to second, right? And you convert it by calculating the number of seconds in 1 year. 365 24 times 60 times 60. Okay, this one almost got it right. Use the equation, which is fine, right? But here's the thing, what's small n? If you want to use this equation, can. What's small n though? Small n is the number of half-lives that has passed. The half-life is what? 27.7 years. How much time has passed? 5 years. So how many Earth of a half-life is that? 5 over 27.7. So n is equal to 5 over 27.7. A over A naught equals to half to the power of that value. Then you can get the ratio already. Okay? Got to remember what you want to use this equation, can, but you got to remember what small n stands for. But maybe at this point in time you're panic already, cause running out of time. Then some of this big ass question comes out. Okay, both HL SL. Oh, this binding energy really damn doing me, Wow, somehow at June holiday I keep emphasizing you all better go and pay attention to binding energy. Because the thing is this, they messed up last year's CT on binding energy. This is their way of redeeming themselves. Huh? You didn't see me send a video the other day. I was ranting about last year's CT. The value they gave, the value they gave for one of these things here was completely wrong. So all my students who did the way I do, right, they all got it wrong. Then never mind. Go back to school. Teacher say, oh, the marking scheme says it's like that, so we just follow the marking scheme. You all know this, right? You all must know this, right? This is a fission reaction. This one releases. They tell you there's unstable to stable, right? This one releases energy, right? Okay. All right. What happens to the total BE? What happens to the total BE, guys? Like the total BE here and the total BE here. What happens to the total BE? Huh? What happens to the total BE one more time? It becomes a larger value, right? It increases, right? It becomes a larger value. And this was that thing that was harping on like, during the June revision, because I keep saying that it's very likely they're going to come up with some total BE question again, because they made a big mistake last year. They're trying to they might try to fix it. But it's not even this rotation of teachers, the other teachers, the shadier ones. So yeah. Okay, so anyway, yeah. I mean, no, that, hey, hello, hey, don't play race lah, right? Racial harmony day, right? Today, okay, all right. No, I said shady. Then the fellow, okay. Hey, what do you do? I go and find the binding energy of everything, like everything. Like what's the total binding energy of uranium-236? Hey, oh, they give you here. Oh, they give you here. Is it 236? Is it? They didn't give you the first one, It's not 235, right? They give you 235, right? So that means I have to circle the other thing. That means I have to circle this one. This one here. This is that unstable, that monster that I was showing you, right? The neutron goes in, then the 235 become a 236, like very unshapely, that kind. Then he breaks into two parts. Lithium and bromine. Yeah. Anyway, yeah. So total B. You all can find the total B or not? They tell you the BE per nucleon is 7.3728 MeV. Okay, hey, English, right? What does this mean? In English, you don't have to explain it, but I want you to understand it. So what does it mean to binding energy per nucleon of uranium-236 is 7.23728 MeV? Wrong. Come on, anyone, what does this mean in English? I want you all to translate to the English because you don't understand it, right? I'm going to help you to understand it now.
Energy between two.
Wrong. Where got energy between two nucleons? Huh? Okay, fine. She's going with the definitions. You're not wrong, but that's not my preferred way. She's almost there. Right? The idea here is this. Uranium-236 requires for every nucleon for you to pull out of the nucleus. Wait, okay, firstly, this is the nucleus. Are all the nucleons bound to each other? Right? They're bound to each other, right? Do they split easily? No, right? They're kind of like stuck, right? So the idea here is this. I need about 7.3728 MeV for every nucleon that I pull out of the uranium-236 nucleus. I pull one out, I need 7.3728 MeV. I pull another one out, I need another 7.3728 MeV. I pull another one out, I need the same amount of energy. So the question is this, what's the total energy required to break the entire uranium-236 apart? This number times 236. It's a big number. It is a big number. Big number lah. Right, so 236 times 7.3728 MeV. That's the total BE. Right, that's the total BE of this number. 1739.9808. Leave all the decimals in. Right, I told you before, this kind of calculations you cannot round off at an intermediary. Leave it all in. Okay, then what's the total BE of the other side? Oh, no wonder. That's why I say this fellow who set the paper, every step got one trick, you know. Yeah, this fella really got every step got one trick. But anyway, you need to know that the total BE here is larger, right? Okay, so I'm gonna call this the A, and this one here is the B, right? The B, right, which is the total binding energy of the products, is equal to A plus 197. Right? The total BE, B is equal to the whatever BE you have here plus 197. But this one is can get one. Let me see. 7.3728 times 236 minus away wait. Yeah, wait. Okay. Wait. Now the reverse happens. Okay? When you're calculating mass, right, you have to consider the mass of the neutron. When you're calculating binding energy, right, neutrons have no binding energy. Neutron, the BE is 0. Because they're individual neutrons, they're not bound to anything.
Wait, so they only possess binding energy when they are.
Oh, yeah.
That would be the case, I would assume, yes. Yeah. That's why you see, I see the 3 times the 940 here. That was like okay, wait, who wants me to check this? Who? What's this? Why? 139 minus 1739 minus this one here minus should be plus. Yeah, should be plus. Yeah. That's why I say you need to know this very clearly. You need to know the binding energy at the end is larger. That's why you need to know this. Like this value here, B, is actually the initial binding energy plus the 197. So I feel very bad for y'all because I knew that this thing was gonna come out. I kind of like had this very didn't emphasize on this enough.
Yeah, I think it does like 3 diagrams.
Yeah lah, correct lah.
Wait, they had so many questions.
They never test anything on stars.
No, but that's a worrying thing. That means either your prelims will come out, or if you see, I think the IB might also come out still. Okay, anyway, the binding energy fiasco done already not? This one?
Yeah.
Everyone settled already? You understand this already? Okay, Okay, good. So, if you still feeling worried about this, what do you do? No, don't do the practical, do more practical, find more practical. What, you still anxious, you go and watch video. You already know the concept already, just go and do more practice, just go and work it out, I think do more video. What? Watch the video got therapy on got therapeutic is it? My normal lesson to do scream at people. Today I'm screaming. Why do you think I have to prepare this thing? Okay, moderator. Someone escaped with a shitty answer. I saw someone's paper. Someone escaped with a shitty answer. What's it? The moderator is to. You have lah. Nonsense. You have lah. Moderator. What? Something like is to reduce the heat lah. Huh? No. No. I know already. Someone escaped with this. Someone said the moderator is to absorb the neutron. Yeah, you got the mark? Huh? No, but someone else wrote it and got the mark. Yeah. Anyhow, I tell you, sometimes these markers are also, every year I damn do it because of this also.
They don't like
Because control means what? 你要 fast 还是你要 slow? Moderator's main job 就是 slow down neutrons. Yeah. Yeah, correct. Hey, okay, moderator. Okay, what's the first? Okay, what do you mean by what? Okay.
Transfer but I don't know.
Actually, it's not wrong, you know. Hey, actually, it's not wrong. Actually, not wrong.
It was transfer somewhere.
Yeah, transfer.
It was slowing down
Transfers.
I remember this from.
Slow down neutrons to allow more fusion rate. Yeah, this is unfair. They shouldn't mark you down for that.
Oh, really?
They're unfair. This one unfair.
You see, if you do it,
The moderator is to bring the heat to the exchange. Cannot be. I'll bring you. I'll show you the textbook. Can you remind me to show you the textbook for that? Yeah. You send textbook. Oxford. You ask her. Hey, how come Oxford wrong? Ask them to edit the textbook. Okay. SL got ideal gas. HL is what? Okay. At this point, it's quite late already. We've settled quite a lot of things. SL, do you have any other questions for question 7? SL? SL?
why is it like a lot of us read the script but apparently
Why is
Okay, what? Okay, wait. It's constant temperature, isothermal. Wait. Are you tested on this?
The graphs. How the graph of the relationships.
I thought I could catch that. Fine. Okay, fine. Yeah, it is a curve. Wait, I look at your answer first. A lot of people cross out. Huh? Go. What do you say? So that you cannot. Moderators don't cool the site. I mean, moderators transfers the heat for the heat exchanger, yes, but it doesn't cool the site. Okay, you cannot write something and hope that they can interpret it in the correct way. You have to, okay, key phrase, okay? It is to slow the neutron down. That's it. Do you write that down? You didn't, then you lose mark. I don't know. You can go and find your teacher on this. I mean, I don't see anything wrong. To me, I don't see anything wrong. Okay, all right. But it's just that, Mark, what's the problem sometimes with communication? Sometimes you write something right, then you make them think right. If they have to think, they'll not just mark you wrong. You understand what I'm saying? Like if you just had said, right, oh, to slow the neutrons down so that further fusion can occur, right, you would have gotten the mark straight away. But because you wrote it in such a way that you are making them think about your answer, like, so that the neutrons do not move so fast. Yeah, correct. So you're making them think, and you know that they can't think one. Wait, you want to ask how to draw the graph, is it? But why is it a curve? Basically, you just need to find the next other point where PV is a constant. You understand what I'm saying? You see this one, right now the P is what? 6, right? And the V is what? 8, right? Okay, 6 times 8 is? You go and look at other points whereby you get the y-axis times x-axis give you 48. You go and mark out those points, then you get a curve. Like that one there. 3 points will do, you can get a curve, yes. Then, mark down.
But you see, you try to set it PV equals
Walao, nonsense lah. That means you want you to write the equation. No, that's not fair, man. No, obeys the ideal gas law. Then she got marked down because she didn't write PV equals nRT. Then you got the mark. I told you already. It's a system marking for that one. Oh my gosh. Oh no. Huh? What? Hey. Actually, okay, these 2 marks can give. I also don't know. I really also don't know. Yeah. I mean, uncontrolled fission. If it's uncontrolled, right? Basically, it's at the exponential end of it, right? 1, 3, 9, 27, 81. You know what I mean? Yeah. Do you understand this now? Do you understand why uncontrolled gives you all the energy? Because at the end, the number is exponential. The number of fissions is the exponential number. Huh? I would just say that towards the end, the number of fissions that occur reaches an exponential value, right? Because every fission results in 3 further neutrons, right? Which can cause more fission, so it becomes an exponential increase. Can? Did you hear what I said? Okay, yes. Okay, wait. HL has this, but it's not your syllabus. Then you have to know how to do this. Okay, you have to know how to do this. Okay, this one, yeah, this one, oh my gosh. That's so man. What? So wasted, there's so many marks, you know. Actually, so wasted, you could have gotten it. Like, how many marks is it total? I think at least got 8 marks more, like, bro. What?
because Keegan didn't just write obey the idea gas law. A gas that has a negligible intermolecular process, that's obey the idea gas law that all parameters available.
Oh, okay. He give a more complete answer lah. What?
Hey, I just wrote follows P equals NRT and
I think it's PV.
Yeah, I think it's PV equal now
One
too.
is one.
Yeah. How to tell, right? Sometimes how to tell, right? I thought like by writing ideal gas law 就是 PV equals NRT,
You
right?
check the papers and you send the answer sheet where they had this.
Was it?
Yeah.
Walao, okay. I have no idea, man. Okay, now I know. Alright. So this one, you have to go and check apparent brightness. That's the why I went to B1.
Okay.
This is why I went to B1. But okay, I think if you recognize the equation, you sub in, don't make mistakes on the subbing in of the values, you should be able to get the answer.
How you doing?
What do you do here?
How you doing ratio?
What do you do here?
How you doing the ratio of
Okay, hey guys, but watch out, listen up, watch out. Okay, listen up. This one quite important. Okay, so I've seen some of your calculations. I also just noticed this. Some of you go and sub in the D, right? The distance, you go and sub in the light years inside here like this. While you're comparing, right, it's not wrong. Actually, it's still okay. But it doesn't give you the true the correct value. You understand what I'm saying? Because technically speaking, D is supposed to be in meters. You cannot just sub in L light years into this thing here, 49 like that. Yeah, I mean, because if we are comparing as a ratio, it's okay. But if the question suddenly asks you, state the apparent brightness, right, of Polaris, and then you forget, right, you can put 49 inside Habis, right, you lose the mark also. Yeah, I mean, if you did, then that's fine, right? I mean, that's what you should do, but of course you have to do it correctly also. I don't know what happened here. I don't know. I don't know. I can't tell. Did you get a mark or not? Oh, okay. Then I'm sorry, I don't know. How to tell? How to tell? You forget a square? Ah? No. L. You can check working. I can't check it now. Okay? Okay, okay, the rest of these questions I'll go through next time, okay? All right, I think there's nothing that's urgent now that you can't do. I think this A, B, and C unfortunately are just plugging in equations only. Right? If you plug in the Stefan Boltzmann's equation, right? L equals to sigma AT to the power of 4. Right? You should be able to compare the acceleration, the radius, right? The surface area. Ideal gas. Okay, and then the last one, the last one. This one here. No, no issue, right? Got issue not?
The last one.
Last one ah. Which one? This one ah.
Yeah.
You four marks. What? Use the graph in C to determine K without its uncertainty. What? HL ah. Oh, hey bro, the graph is V squared against T. Yo, Jethro, the graph is V squared against T, right? But the equation is V goes to K square root T. So they want you to find K. So the gradient here is actually V squared versus T, right? So the gradient here is not directly K. You need to square it. You square this gradient, then you get the answer. Oh, you need to square root this gradient. You get this gradient already, you square root the value, that's K. Huh? That one's no problem. Right, I'm saying the K, they're trying to be fun. You know, every question got one trick. Every question one trick, this one. Too much. Okay, I'm calling it 2 hours already. Right, go back home. Okay, go and do your corrections. Slowly go and do your corrections. Go and do it. Go and do your corrections for all your other papers. How are your other papers? Okay, how's your other papers? What? Okay, go and get it done. If you're still unsure of any parts, please let me know. Right, if you're unsure of any parts here, please let me know. Right, I'll go through with you either on WhatsApp or when I next see you. Right, give me time. Right, I'll come back to you. Okay, hey, someone asked me whether these papers are easy.
What's your conclusion?
Okay, difficulty on the level of 10. Okay, this is probably 8 actually. Yeah, this is like an 8. Only because of after I realized all the little tricky bits, it's like a difficulty of 8. Yeah. But you have to be sharp. You have to watch out for all these tricks. Always remember, like you see, right? The way I approach teaching you guys, right, is I always want you all to be on guard against your teacher because your teachers are nasty, right? They will always give you these little things here to trick you, to make you lose marks, to cause you problems on. So you got to be on guard against them, especially for prelims again. Okay? All right. Thanks, guys. Those online, thank you very much. Thank you. Bye.